videos, we have covered core animation sheets, background maps, classes, collision maps, entities, entity pools, fonts, games, images, and we have also covered loader, map, music, sound manager. So what remains is input, system, and timer. So we are going to, in this video, let's see if we can get through the remaining three things of the input, system, and timer. And then what might remain is things like doing minification or using the level editor or other things like that. We'll leave those for later, but we'll try to get through the class reference at this time. So we have been making good progress as well on some of these topics like entity pooling and animations, collisions, assets, etc. So let's continue, and we will in this video try to get through system, input, and timer. So let's start with input. So input is basically defined in the impact input module, and it inherits from IG class. So the synopsis is basically, it's really simple. You can define inputs as what that input is and give it kind of a name. So in this case, we are saying that the input with the up arrow key, ig.key.up arrow, is going to be binded or mapped to the jump keyword. And if ig.input.pressed jump, then we are going to change the velocity, the y velocity, to -100, for example. So the description is it handles all the keyboard and mouse inputs. You can bind keys to specific actions and then ask if one of these actions is currently held down, the dot state, or was just pressed down after the last frame, dot pressed. So like we can see if the mouse is, the left button is held down, or if the left mouse button was just pressed, right? Or we can also see for an arrow key if the space bar is being held down, or perhaps it was just pressed. So we can check the state of the key. We can also see if it was just pressed. Note that the instance of the input is automatically created at ig.input, lowercase, by the ig main function. So we don't have to go and create the instance of input. It's created for us already when we declare the main. So properties are like acceleration, x, y, and z. This is the acceleration of the device, like the mouse, or it could be a touch or accelerometer. Okay, well, I guess in this case it is for the accelerometer. So this will be 0 for devices that don't have an accelerometer. So basically, if you are building a game for, let's say, an iPhone which has an accelerometer, you could detect how fast this iPhone is moving in the X, Y, and Z directions, or how fast it's accelerating in those directions. Mouse, X, mouse, Y is basically the cursor position of the game in pixels. So note that this position is only updated when at least one mouse button is bound to an action. If you haven't bound any mouse buttons, you can call init mouse yourself once to start capturing mouse input. Methods are bind touch, init accelerometer, init mouse, pressed, release state, unbind all. And then we have this section on mouse and keyboard button names, which is basically a reference. So I think it's important to say the button names are basically ig.key. Also, it's not just the keyboard keys. ig.key includes the mouse names: mouse 1, mouse 2, mouse wheel up, mouse wheel down. And remember, not all mouse have wheels, so if you're building a game, you want to make sure there's other ways to do things without having to use the wheel. And then you've got the A through Z keys, you've got the number keys, you've got the special keys, delete, home, backspace, all of those. Got the numpad keys. Again, a smaller keyboard like a MacBook keyboard might not have a numpad, so be careful with that. And then your F keys. So basically all the keys that you can think of on the keyboard are here. And unbind will just unbind all the keyboard, mouse, and touch buttons. Unbind key will unbind a specific key. State will return true if one of the buttons bound to the specific action is currently pressed down, false otherwise. So you can pass in an action, and you would get back if one of the buttons bound to that action is currently pressed down. Released will return, again, you'll pass in an action and get a true if one of the buttons bound to that action was just released. Pressed, again, you pass in an action and it'll return true if one of the buttons bound to that action was just pressed. In contrast to state, this method only returns true once for each button press, and you can use this. So state will keep returning true, right? But because the state could be true if it's being held down, but pressed will only happen once. And you can use this, for example, if you want the user to repeatedly press a button to shoot instead of having auto fire, like just holding a button down. Init mouse is basically going to capture your mouse input, XY positions. This method is automatically called as soon as one of the mouse buttons has been bound. Be careful when using mouse input for a game that runs in an iframe. The event handlers for mouse input will call the events prevent default. Method to prevent selection, right-click menus and dragging the canvas as an image, etc. And so, however, this also prevents your canvas to be focused, which may prevent to receive keyboard input. To work around this, you have to call the IG system canvas focus yourself to get keyboard focus in the iframe. And then we've got the accelerometer inputs. Binding a key to an action or a selector to an action. So we spoke about this, like you can say that, hey, the space key is jump or the up arrow key is jump, and that's the binding, right? And jump is the action. So basically when you said pressed and then gave it the action, you're basically saying pressed and then jump, and whatever the key for jump you've mapped it to, those will tell you. So that's binding. Binding touch is essentially selector with an action. Note this is a bit cumbersome to use. Consider using touch button plugin instead, as it will work in mobile browsers as well as in Ejecta. Bind an HTML element to issue the specified action when the element is touched. This will only work for devices that implement the touch start and touched events, currently iOS and Android devices. The element specified by the selector must already be present. It will not be created by Impact, so the selector can only be an ID selector, example hash button. And so you need to make sure that you've already placed that particular touchable element onto the screen, and then you can bind touch with that element. So for example, you can create a button which allows, when you press it, it allows you to jump, that kind of thing. Properties, accelerometer, and mouse. We already spoke of these. So that's it for the input. We are done with input. Let's move on to system. Actually, let's do timer first because that's maybe shorter. Yeah. Timer, you basically get a new ig.timer to create a timer, and then once you create it, you can basically call .delta. So whenever you call dot delta, you will get the next time from the timer. So when you initiate it, it will be 0. And then once you, for example, do dot set of 5, it now becomes a delta of -5. And a second later, it becomes -4. And then 5 seconds later, it becomes 1. And so on. So basically, the delta is actually tracking the time, right? And you can set this timer into the future by using the set method. So if you create it, it's time 0 right now. And then as time passes, it becomes time 1, time 2, time 3, time 4, like that, right? But if you set it to something in the future, we're not yet there, and so it's negative time. Did it make sense? So, like, just to be clear, let's say that you set the timer. So right now you're at time 0. And now time starts elapsing. So it's been 3 seconds. 1, 2, 3. But then you go off and you set it to 10. So now you're actually at -7 relative to the 10. Right? Okay. Description. The IG timer has 2 distinct modes of operation. You can either get the difference dot delta between the current time and the timer's target time as set by the set, or you can also have set it in the constructor, or just get the current tick, the time since the last call to tick. And all timers are only updated once for each frame, so calling delta on one timer several times during a frame will result in the exact same return value. IG.timer does not measure real time but game time, and game time can progress slower than real time when the browser can't keep up with executing the game loop several times. The default is 20 times per second. See the max step. How fast the game time progresses is also depending on the global timer timescale property. And so be aware that all time intervals are in seconds as opposed to JavaScript's milliseconds. The constructor takes in the target time. The default is, of course, 0. The delta we just talked about returns the time in seconds relative to the target time. And resetting the timer will set it to the start of the next level. Reset the timer at the start of the next level. Well, I guess they're saying at starting a level, you've started the timer, there's no target time, it's now at the end of the level. You're saying the time needed was however much ever time the player took, and when you're setting it, you're setting it again to now. So this code is basically timing how long the player took to play the level. Pausing the timer pauses it, and it will stop incrementing the game time. Well, I mean, it'll stop incrementing the timer along with the game time. You can also unpause, set, or reset. That will unpause the timer. Unpause, reset, set, tick. So tick basically gets the time since the last call to tick for the timer. So note that since IG.timer represents game time, it does not update during a single frame. So yeah. A global tick updated each frame is also provided at ig.system.tick. So you can also use the system tick if you don't want to use your own timer for certain things. Global properties, IG timer max step and IG timer timescale. The max step is the maximum time step. The game will never advance more than this per frame. The default is 0.05, which is 20 frames per second. So if the browser is unable to run at least 20 frames per second, then the game will be slowed down unless you change the max step. The time scale is 0.5, and the game will run in slow motion. Sorry. With a value of 0.5, the game will run in slow motion. With 2, it will run at twice the speed. The default is 1. So this is basically helping you map your frames per second to how the game clock works for your game time. All right, so that's the timer. And last but not least, let's go over to system. So the class reference for system, basically the system is taking care of all the starting and stopping the run loop and calls the .run method on the game object and does the housekeeping for IG input and provides some utility methods. IG system is automatically created at the main IG main as IG.system in lowercase. So you don't actually need to run the constructor for IG system yourself. It will be run by IG main. But if you wanted to, this is how you would run it with the canvas ID at frames per second with height and scale. Okay, properties are the canvas element, the context, the frames per second, which is obsolete in 1.20 because we said it's now using the request animation frame from JavaScript instead, which is more robust and uses the browser directly. Real width, real height is the scaled size of the game screen. So, for example, if you had scaled it up to a factor of 2, and it was 320 pixels, then the real width would be 640. Running is true if the game is running, false otherwise. Scale is the scaling factor. Smooth positioning was removed. See the system's draw mode. So the draw mode can be authentic, smooth, subpixel. We said smooth was removed just now. Smooth positioning as a property was removed. Tick the time in seconds since the last frame. Use this for movement calculations and the like. So remember, this is game seconds. Position. Note that it's not real-time game, but it's game time. If for a second instance browser is unable to run the game, the whole game will be slowed down, and the tick will be slower than the real time, and so on. So we spoke of that in the timer. So this is the system tick. Remember, we also had the timer tick, which was on a tick on the timer that we create, and there's also this generic tick on the system itself. So this is the tick on ig.system.tick. We can do things like multiply it by the velocity and add it to the position to calculate the updated position of an entity. The width and height is basically the unscaled size of the game screen in pixels as set by the constructor. So if you want the real width and height, that's the scaled version. If you want the unscaled version, you can just do .width.height methods. Clearing, passing in a color, will clear the game screen with the specified color. IG games draw method calls this clear for every frame with the game's clear color. Get draw pose. P gets the real target position for drawing into the canvas. This takes the scale and the draw mode into account. You only need this method if you work directly with context instead of drawing through IG image, IG font, or IG background map. So here I would like to mention that in my experience with the IG font, I did not exactly enjoy using IG font because the font editor is kind of broken and I need to make those images of the font and stuff like that. I found it much more convenient to simply get the IG system context, the canvas context directly, and if I'm going to draw text on there, just use the font classes from the canvas itself, the default ones provided in the HTML canvas. And then using that, I can easily just use Google Fonts and all the other fonts that I want and draw them on my canvas in my game as needed. And so all I have to do is within the entity or anywhere in my game, when I need to draw text, I just prefer to use IG system context fill text. And that's what they're showing here as well. And then to draw it in the right place, you can use this get draw position X or draw position Y, or to decide where on the screen you're drawing that text. Okay, so that's a much easier way to draw fonts. For images and for background maps, yeah, I still would use the IG methods. All right, so resizing is basically if you want to set the width and height of the canvas element in unscaled pixels and optionally the scale parameter. Setting the game, passing the game class. So you can run the specified game. It stops the currently running game and adds a new instance of the game class and starts running the loop again. This method is safe to call anywhere in the game, as the new game will only be started after the current frame has finished updating and drawing. So normally you're not going to be switching games, I assume, within the game, but you might. I don't know. Global properties are essentially IG system draw mode and scale mode. So the system has two global properties, draw mode and scale mode. And the draw mode can be authentic, smooth, or subpixel. The default is smooth. Specifies how the graphics are positioned when drawing. Authentic rounds all drawing positions to unscaled pixels. Smooth rounds to scaled pixels. And subpixel does not round at all. So example, if the dot scale is 4 and the draw mode is smooth, which would round to the scaled pixels, moving an entity will move it 1 pixel at a time. If draw mode is authentic, the entity's smallest movement step will be 4 pixels. So basically, setting the right draw mode and the scale will determine how your entities move on the screen. And while smooth is somewhat unauthentic for pixel-style games, it provides much smoother movements of entities and background layers when the game screen is scaled up. So, yeah, so basically you have, a screen and you're moving according to that screen, but when you scale it up, you're going to get, kind of a pixelated movement. And by changing it to smooth, you can fix that. Note that not all browsers support subpixel drawing, and so depending on your game, subpixel positioning may lead to visual artifacts such as seams between tiles. In most browsers, it also comes with the price of a bit of performance, and you have to specify the draw mode before calling IG main. And yeah, so basically my recommendation is leave it as smooth unless you have a reason not to. IG system scale mode. There are 2 different scale modes, crisp and smooth. The default is again smooth. Specifies whether to interpolate images when the canvas is scaled up. Use crisp if you want a pixel style game. You have to specify the scale mode before calling IG main. So again, I don't see with most modern games why you would want to pixelate the game, but maybe you do. Okay, so that's it for systems. So in this video, we have covered inputs, we have covered timers, and we have covered the system class. So that provides these helper methods like clearing and drawing and resizing, kind of the canvas related things, and the game tick, and yeah, so kind of the game system details. You're not going to alter much of these system thing directly, I guess. Anyhow, this is good. And I think now you're ready to actually start creating a game. We have been through all of the class reference documentation at this point in the earlier videos and this video. We haven't gone through any game creation, the level editor, or things like debugging or packing up the game like baking, or other tools. But we've gone through all of the core classes and things you need to start building your game. So I hope you've enjoyed this series so far, and I will later make some more videos on the remaining topics here.